EVT, IVT, MVT, sort of conceptual ideas, and we're going to have our number line, and we're going to look for a max or a min using a change in sign from a positive to a negative. So optimization problems were among the earliest applications of what we call differential calculus. So if you go into engineering, you'll take a class called differential calculus or diff-EQ. That's why in calculus, we primarily don't focus so much on this anymore, because if you go down the route of a mathematics degree, there's an entire class on it. So AP and Calc 1 kind of pushed away from it, and now it's being turned into its own course. So the question is to find two numbers whose sum is 20 and whose product is as large as possible. So if we're looking for two numbers whose sum is 20, yeah, but I want you to do it calculus-wise. So their sum is 20.
Where is this?
Do you have this one? See, I told you I cut down your problems. Do you have the farmer?
Yeah. Was the answer penitent?
Yes. Because the square is optimally the most optimal. A farmer has 1,200 feet of fencing, 1,200, 2,400 feet of fencing, and wants to fence off a rectangular field that borders a straight river. So here's the river. There's my green field. They only need to fence where there is no river. So I need fencing along the widths and one length, but not the other. He needs no fence along that river. What are the dimensions of the field with the largest area? So we have two formulas we're going to kind of play into each other. We have the perimeter of the fencing plus the area of the field. So perimeter is length plus 2W, because we don't have two lengths because we don't have the river. And area is length times width. So what are we trying to maximize? What is our end goal? We want a large area, right? We're looking for a big field. So what we're going to do is take perimeter and plug it into area, because our goal is to get area in terms of one variable. Because right now, if I derive area, I have two variables. So our goal is to get area in terms of one using perimeter. So the perimeter is the amount of fence I have. So at most, the perimeter can be 2,400. And then let's say we solve for L, because it won't involve division. So exactly, you're going to subtract 2W to the other side. So it's almost like a substitution or a system of equations problem, where you subtract 2W and we say, okay, well, L is the same as 2,400 minus 2W. So area is the same as 2,400 minus 2W times W. Or 2,400W minus 2W squared. To find a max or min, precisely, you take your derivative. And where do maximums or minimums occur? At the zeros of the derivative. So you set your derivative equal to 0. we get that the W, or the width, has to be 600 feet. It said, what are the dimensions? So it means I also need to know the length. And you're done. If you would get more than one critical number for W, then you would have to do a number line and find which one was the actual max for some min. Yes.
So, isn't it like, don't you already know that a square is going to be your largest area? So couldn't you just like work backwards?
It's not a square.
But like, technically, like
Technically,
600, so then like 2L, because you're doubling your length. Doesn't it work out?
yes. However, do you think all calc problems are going to stay like this?
True.
Like we're going to get with decimals, or we're going to get. So the idea of this is exactly what you're doing, to think. To think, okay, what is logical or what happens? And to get you back into the process of, okay, where do maximums occur? They occur at the zeros of the derivative. If you think about it, what?
That's actually bigger. But then what Anna said, just divide by 3 to get them all the same.
No,
Oh, she said 2.
Yeah, because you would assume
She said make 2 squares.
And then you know that you don't have a length on that side, so then the second side would just you double the length.
Oh, cut in half. Okay,
Yeah.
never mind.
Okay? So usually when we have a lot more time, but like I said, I want to kind of push forward. There's some more stuff we have to do. I have you actually take a piece of paper and cut out the corners and like try to make your own optimized box. And then we do the actual algebra to it. So it says a sheet of cardboard that is 3 feet by 4 feet. It doesn't matter which way you label it. So like if I label this 3 but you labeled it 4, it'll still all work out. Will be made into a box by cutting equal size squares. So that's the key idea, is that we're cutting squares. That's why it said it doesn't matter the way you label it. So each of these are a square, which means they have to be the same height and width. And folding up those corners, what will be the dimensions of the box with the largest volume? Okay, so easily enough, think about if you cut out this corner of a square here, and then you fold up that sheet. What does that make the height of the box? X. The width of the box would be this length from here to here, right? So how do you come up with a relationship between what we have and what we know? Perfect. 3, so that's the length, minus both these, which are actually x. So this whole length that we care about would be 3 minus 2x. Which means this piece right here would be, yep, and your height is x. So we have length, width, and height. So volume is length times width times height. Well, the length is 3 minus 2x. The width is 4 minus 2x. The height is x.
You take the derivative of that, I guess. That equals 0.
Yep. If we're trying to maximize volume, we need to derive volume. I would highly suggest foiling all of that out before deriving. Because otherwise you have like first times root of the second, which would be a product rule within a product rule. Yes?
I may have missed something. Cool. But why do you take the derivative of the volume?
Because that's going to give you the critical points that maximize it. So volume is cubic. I get a cubic function. Kind of makes sense, right? Derive it. What am I going to get?
12 minus 28x plus 12x squared.
So cubic becomes a quadratic. What would I do to make this problem easier?
4.
Is that factorable? Can't remember. Is it? Fred, what'd you get? X minus 1 and yeah, x minus.
Negative. Yeah, he works.
So you get two positive solutions. You have 1/3.
It doesn't work. That needs to be a 6, not a 7, so it doesn't work.
I have 1. Oh yeah, because you
Oh,
get
yeah.
9.
It doesn't work.
I didn't think it was factorable. Where's that on my? It's like the one time I don't have my book in front of me. Because I feel like I got like a gross answer. Like I feel like it should be like x equals 1.7.
You get either -10 or -6.
No. When you do like the quadratic
Yeah.
formula, like I feel like we get 1.7 as an answer. So you don't have to worry about the 4 because you could divide it all out. So like when you do quadratic formula, you only have to concern yourself with the inside. Not word balances, it gives me a headache. X with 13.
Root of 4, 6.
1.76. I said 1.71, and that was based on a whole year ago. Just kind of know my answers. Okay. So that value, because the other one is going to be negative, would give you your answer. Just do those 4 problems in your textbook. 3, 4, 9, 10, 2, 2, 6. I'll text it under mine too. I'll do it right now.
Do you want those things?
Oh yeah, guys, I can't let you keep that AP problem. I forgot. That's a non-released one. Just leave it on your desk, so I'll collect it.
We didn't release one from 2002.
It's non-released, which means you can't take it out of this room. So make sure I get that back with your name on it. I'm going to put it in a folder I keep in here for you. So as we get closer to the AP test, we take like a bunch of these back out and we like look through them and thank you, Anna. So like I said, I'm going to keep these, and then when we get closer to the AP test, I will give these back to you. And you'll look at them and you'll be like, wow, like I can totally do that way better now. And some of you might be like, wow, I totally forgot how to do that.
Well, wow, I think I did the worst.
Yeah.
You what?
Nothing.
Not a negative remark, Tom.
Towards myself.
Towards yourself.
No, you never make some
So is today not a math tutoring day?
It's Friday.
Yeah.
It's Switch they just.
But see, I thought like they made today Monday. Like, why wouldn't they just push every day back?
They did that last time.
Yeah, why wouldn't they?
It's kind of smart in my opinion.